Hello, this is Sam from Serious Games, and today we're going to take a look at how to make a 2D joystick aiming system in Unity. Alright, so to get started you want to make sure that your arm is disconnected from your body like so, and that it can rotate freely. You also want to make sure that the pivot point is in the right spot, because otherwise it will cause you a lot of strife down the road if it's not. And you want to make sure that it's right on that shoulder there. So go ahead and hit apply, and we're almost ready to start scripting. There's just one more thing we have to do, and that is go into project settings, input, and we have to add two new axes, and we have to call them horizontal right stick or vertical right stick. You want to make sure that the gravity is 0, the dead is 0.19 or 0.2, and the sensitivity is 1. The horizontal right stick uses the fourth axis, and the vertical uses the fifth axis. Alright, now that we have that, we can go ahead and create a new script and call it Joystick Aiming. I already have it made here with the full script put in here so you can see what it is before we go through it and break it down. So, as you can see, we have the whole script. It's not super long. It's actually very simple. Alright, I'm going to delete it, and I'm going to go through it with you and show you how it works. So, now that we have here is we have a reference to our run script, which is just any movement script that you have applied to the body of your sprite, or whatever the arm is parented to. The public transform twist point is your arm, and your return time is how long it takes the arm to return to its base position. In your void start, you want to have your run is equal to game object defined object of type, so that you know what it is, or excuse me, so that your run knows what it's accessing, so you can find it and use it. So now, to get started, we want to make a new public void and call it aim. In it, we want to define both of our horizontal and vertical axes so that we can use the ones that we defined earlier. And so we want to have that equal to get axes, and this is where you put in the name of your axis that you defined, and we call it horizontal right stick. And so now you just want to copy that and change the horizontal to vertical. And after this, we're going to show you that there's really only one line of code that you need to make this work. And that is the twist point dot transform dot local Euler angles is equal to new vector 3. And this is where things get tricky and why this is hard to figure out. You want to make this a mathf dot the arc tangent of 2, or the atan, and to find the angle you have to take the arc tangent of both your axes, and this is just a little bit of trigonometry here for you, is why this works. And it's going to give you that output as a radian, and so you need to convert it into degrees. And so to do that, you just multiply by 180 and then divide that by mathf dot pi. And then just go ahead and add 90 degrees to it, and that'll make it so that it is where you want it. It's kind of an offset. So after you call aim in your update, you go back into your editor, and it should be working just fine. So if in your inspector, you drag your arm in here, you're ready to try it out. You'll see though that we have a problem here. It just keeps snapping back to that vertical position. It'll follow your joystick just fine, but it snaps back. And so this is where the functionality comes in, and this is what the rest of that code is. And so just to get started here, we're going to define a new vector 3 and call it angle and make it equal to twist point dot transform dot local Euler angles. Cool. Now, to make this work right, you have to test and see if there's any input. And to do that, we want to see if the horizontal axis and the vertical axis is equal to 0. And if that is the case, then we want to have a vector 3 called current rotation that is equal to twist point dot transform dot local Euler angles, and a vector 3 called home rotation. We want to make sure that those know which direction to return to if there is no input. And to do that, we want to say, is the current rotation dot z, because we're looking at the z value, greater greater than 180 degrees? And if it is, then we want to set that equal to a new vector 3, 0f, 0f, and the 359.999f, because this makes it so that it doesn't return exactly to 0, and it won't run that if statement again. So go ahead and make an else statement now, because that's only one direction, and make the home rotation equal to vector 3.0, and we're good to go. But now we have to make it so that it actually returns, because we don't have any script for that. So to do that, we're going to say that the twist point dot transform dot local Euler angles is equal to a vector 3 dot slurp, and it's going to start at the current rotation, go to the home rotation, and it's going to take time dot delta time multiplied by the return time that we set earlier to get there. And now there's one more thing that we have to do before we can test that. And since this is all in an if statement, we need an else statement for the twist point to go in, because if there is no input, else, we want to be able to move the arm. So now that we have that, we can save it and go back into the editor. And go ahead and click play. And as you see, we can move and it'll slowly return to that base position. But the arm can rotate all the way around, and that doesn't look right, so we need to change that. And in order to do that, we have to see which direction it's facing. And this is why we got a reference to our run script, or whatever our movement script is, because now we can see what direction it's facing. So to make this implemented, we have to make a new if statement that says run if run.facing direction is equal to 0. And you're saying, oh, why do we do that? We don't have a run.facing direction. In your movement script, or whatever script you're referencing, you want to have a variable that is equal to the transform.eulerangles.y, because if it's facing right, then that y value will be 0, and if it's facing left, then it'll be 180. And so if you know what that facing direction is, you can tell whether or not it's facing left or right. So you want to set all of this in that if statement and have it if it's facing right. Now, we're not going to be able to switch sides right now. It's just only going to work if we're facing right. So in order to change that, we need to have something that allows us to switch directions we're facing when we move the character above, when we move the gun above our head. And so to do that, we're going to say angle, which is the vector 3 we made earlier. If that angle .z is greater than 90, or if it's above the head and less than 200, so this just kind of constrains it, then we want to transform that rotation back to its position before it went too far. And all this will do is stop it from moving past that 90 degrees. But we don't want that. We want it to switch when it gets there. So we want to set that to 89 so that it doesn't go through that if statement again. And then we want to call run.rotate player 180 degrees. And this is a method we have in our run script here that just transforms that parent, that body, so to speak, into looking direction. And looking direction is 180. And so it changes that Y value to 180 degrees, and as we mentioned earlier, that makes it so it's facing left. Alright, now that we have that, let's go back into our joystick aiming and make a new if statement that allows it to go if the arm goes below the feet. So if angle.z is less than 270 and angle.z is greater than 200, then we want to transform the rotation back to 271 because we don't want it to go through that if statement again as earlier. So new vector 3 0 0 271, and then we want to rotate the player to 180. Alright, so now that we have that, we can go back into the editor, hit play, and we'll see that if we move the gun to the top of our head or the arm to the top of our head, it will switch the player's facing direction, but you can't rotate it anymore. And that's because there's no if statement that says if it's facing to the left. And so all you have to do to fix that is copy that entire if statement, move it down, and then say if run.facing direction is equal to 180. And that allows us to move the arm when we're facing to the left. But it's going to be inverted because we're facing to the left, so we have to take this negative 180 in our arm movement code here and take it to just 180. And we're almost done. We want to be able to rotate back to 0, so we change that run.rotate to 0 instead. And in our run script, we have this run rotate player 0, which will transform the Y value of the parent back to 0. So now that we have that, go ahead and save it, go back into the editor, and that's all it's going to take to be able to move this character and have a 2D aiming system with the joystick. So thanks for watching, and if you liked the video, please make sure to like and subscribe, and I'll see you guys in the next one.